Good afternoon, everyone. Thanks for making the time to come out, see my talk here. As with any good academic talk, I hope this begets more questions than provides answers. So that's really my goal at the end of this. So hopefully, if we have a few minutes at the end, we'll open up the mics to talk a little bit. So today, I really want to talk about some of the unintended consequences of technology transitions. We've had a few in most people's lifetimes in this room. And also, we can learn from history about other transitions that happen and some of the things that we can learn about that to apply to the impending or ongoing transition of AI, and really try to move things into a positive place. Stay away from the negative outcomes and actually bias the future towards a positive outcome. I'm Naveen Rao, Corporate Vice President and General Manager of the Artificial Intelligence Group at Intel. All right, so as I mentioned, every technological transition has impacted our lives in some way. One that we often talk about is the Industrial Revolution. So this is where steam engines kind of came into scale, and we were able to build them and actually start offsetting human labor. So before that, you were born into this world and you could move things around in the world and you actually had value, economic value. After that point, that value was diminished, especially in certain verticals. And so that was a pretty big change in the economics of the world and just how people thought about work and what that really meant. And actually, it's really interesting. If you read articles from that time, you'll see very similar themes that you see today concerning AI. Just replace the words of machine or mechanization or something with AI. Very similar kind of theme. A second revolution happened around factories. This was actually our ability to scale manufacturing and modularize components. We started doing this in the early 19th century. Cars, Ford Motor Company was one of the first ones that really pushed this along. And really what this allowed us to do is build goods at much cheaper rates and actually get them out through distribution networks. Again, our entire modern world is based on this, but that was an inflection point in human history. I'm doubting that anyone in this room actually remembers those transitions. If you do, that'd be impressive. But one that, or two that actually everyone in this room probably should be, at least in their vague memory, would be the PC, the computer in general, was something that happened when I was a kid and through the 80s, which was a very interesting thing. I think this whole notion of computer geeks and all that kind of started during that time, and I think now we revel in it as, we won. It's great. But at the time, we were, still ostracized as outsiders. And then the next big transition, of course, was the internet. I think, speaking at an Amazon conference, I think, we should probably know what the internet was. And that sort of changed a lot of things. And we'll get into some of those changes. But all of these things, as impactful as they were, I think will actually pale in comparison to what artificial intelligence will be in terms of a transition. And in a few moments, I'll get into why that is. Interestingly, I think this actually happened through evolution of our species in general. If you look at the way humans evolved compared to other animals and other mammals at the time, it was sort of this kind of linear chugging along of evolution. And then all of a sudden, something happened about 250,000 years ago. Humans acquired enough processing capability in their brains, there was enough of the density, and we had enough I/O capabilities through our mouths. That technology transition, language is a technology, that technology transition actually led to humans being able to do things that no other animal could. It was a state change. And it was a state change that happened extremely rapidly. If you think about, dinosaurs were alive 200 million years ago, died out 65 million years ago. 200,000 years ago was nothing in terms of time, but we drastically changed the face of the planet. So it was just a few different linear trends that led to a very nonlinear transition. And I think we're actually at something very similar to that right now. So I think it's both an exciting time and a time to be very thoughtful about how we apply technology and where we do it. So some of these changes have already started. I'm guessing everyone here has probably heard of Google. Search engine sort of organize information on the internet and fundamentally change the way we access information. I would say we've we've largely outsourced parts of our brain. Like I don't think about particular pieces of information as much. I think about the index of how I can access that via Google, right? That's a change of thought. I mean, I think, scholars in the 1800s used to remember all these texts and memorize things, and that was considered, a scholarly endeavor. We don't do that anymore because we don't need to. And so I think that fundamentally changed the way we learn. And Google's platform is actually one of the biggest machine learning platforms in the world. But there's other recommendation systems that we're seeing permeate other parts of our lives. So Netflix, the way we watch movies now, it's entertainment, so that sounds like, okay, maybe it's not that big of a deal. But if you think about this, they actually caused some kind of a transition. So as a self-professed geek, I used to read a lot of science fiction and watch science fiction movies. Now those movies are driven to you with an AI system. That's a little bit different. And so that'll actually influence the next generation on how they're motivated to build new technologies. So there is something really kind of interesting there, how it changes the world in ways that we didn't really foresee. What we buy. Again, we're at an Amazon conference. The way we buy things now and the way we access technologies and new products is vastly different. We talked about the June oven was mentioned in the keynote, I believe. I don't know how many people in the audience, actually it'd be interesting, how many people in the audience looked it up on Amazon right away? Probably a decent percentage. I did. I was like, oh, that's kind of cool. How much does that thing cost, right? 20 years ago, you'd read about that in a magazine, and maybe a year later, you may see it somewhere at a trade show, and then a year later, maybe you can buy it. So the way we access technology and try new things out has rapidly changed. Like we iterate on these things much more quickly. And again, that changes our conscious experience of the world. And now, of course, we're interacting with machines in new ways. So anyone who has kids and an Alexa in their house knows this, maybe annoyingly so. Kids always want to talk to this and ask it silly questions and ask it to make jokes. But I think what's actually going on is something deeper, is that kids are becoming very comfortable with interacting with machines in this way. I mean, for us adults, it's still a bit of a novelty. I mean, I actually work on systems like that, and it's still kind of like, it's a little bit of a toy. But for them, it's actually a way to access information. They can pull up news or pull up a funny video or a joke or something like that. And so it's a new way to interact with information through technology, and actually has implications on how kids may even interact with each other in the future. So speaking of which, this is something I think is really interesting if you really think about online dating in a really deep way. So online dating seems innocuous enough. We have the internet, we have mobile devices, and let's find new friends faster, right? Great. But 100 years ago, you could only really find mates within your maybe 3-block radius. So the implications on the gene pool are actually kind of interesting. You are biased toward more homogeneous gene pools. Now, I mean, maybe, there's a lot of jokes aside about FOMO and this and that and how it's changed dating behaviors, but one thing is true, that we have a much larger population on which we date and find mates. And that will literally change what our genes look like in a simple generation. And so what is that going to look like in 2 generations or 3 generations? I don't really know. This is a completely unintended consequence of a technology transition. I don't think anyone who came up with a mobile phone thought that our genes would be different because of it. So it's kind of a funny thing I like to think about. So we're at a point where AI really does start permeating every aspect of our lives, not just our genetics, but just our conscious experience of the world. And now, let's think about why that is. So every one of those technology transitions I just talked about, the Industrial Revolution, scaled physical labor. We're able to take machines that do things that 10 people used to do, and we can manufacture those machines and do it very cheaply. We took physical labor, we made it very cheap. The second part of that, manufacturing, took organizational labor, essentially made it very cheap. Computers took organizing capabilities like log books and bookkeeping and made it very cheap and opened up new applications for business. The internet scaled our ability to move information around. It's funny because this impacts us in our own lives. Like, I talk to my own kids about this kind of a thing. It's like, to them, it's unfathomable that I can't just send someone a text or an email or something. For them, information sharing is just fluid, whereas even 30 years ago, it was really, really hard, right? If I wanted to send someone a document, it was maybe a fax, it was probably mail, right? That was how we did it. And now it happens in no time, and we don't even think about it. So the interesting thing that's happening, and this is why I think AI transition is one of the most impactful upon us, is the scalability of expertise. So now it's not just about scaling data or information. It's about taking that information and being able to interpret it to an outcome. If I'm a petroleum engineer and I get information about this is what a seismic survey looks like, this is how many storms have been in this area traditionally, I can use my knowledge and expertise to say that's a good place to drill or not. That requires a human today. Same thing with law or medicine or farming, anything. But once we can take that capability and start scaling it through machines and make it very cheap, it's going to have major implications upon the world. We're already seeing this in academia today, is that 100 years ago, you'd have a paper that's extremely impactful written by one person, kind of sitting by themselves writing this thing up or doing some experiments. Today, our big papers have maybe 50 or 60 authors on them sometimes. It's a reflection of the fact that the problems we're trying to solve are much bigger, sort of the low-hanging fruit's been picked. And in order to do that, we need to collaborate more. So I think we're actually hitting I/O limits on that capability. Our ability to collaborate is actually extremely difficult now. It's very hard to organize 100 people to work on one singular problem. And the way to do that, actually, in my mind, is AI. It allows us to pre-digest information that comes from a large number of sources and observations into something that's digestible by individual humans and allows them to collaborate across this new axis. And this is how we're actually going to solve bigger problems, like potentially leading us to get to Mars. Maybe what this conference is kind of about. AI is really that tool and that capability that we've needed to solve these problems. And I'll give you some examples that make that concrete. If we wanted to go to Mars and we wanted to populate it, is it really feasible to send a bunch of humans up there without knowing a lot of things to start setting up a colony? My guess is probably not. So we need to solve autonomous robots. We need them to work very robustly in a new environment under conditions that we really don't understand yet. Also, we probably have to invent some new kind of engine technologies and new kinds of power technologies to get there. These are hard problems in physics. The only way to do that is really through much more massive exploration of the base science and massive collaboration between humans and machines working together to solve these problems. So bringing it back down to earth a little bit, what are some of the problems that our society needs to solve today that we can actually start approaching? I actually think healthcare is one of the biggest applications for AI. My dad actually had glaucoma, and as a kid, I remember thinking he wanted to go to see a particular person who was the expert at this and could, look at the scans and come up with the right action plan and right intervention. And to me, it was kind of funny because we're basically trying to find the information that's in one person's head. And it's actually kind of silly if you think about it. Why can't we take that information, that expertise, and put it into a computer and make it super cheap so that everybody could have access to that expertise? Turns out that's really hard to do. And it took a good part of my life so far to get to a point where we can even think about that happening. But now we're there. And so that's what's really exciting to me, is that we can actually apply the scale of expertise to healthcare and dramatically lower the cost of healthcare and delivery and accessibility. Same thing's true for farming. This is one of the oldest industries in the world. There's a company called Grameen, which is actually using sensors to do soil analysis and make it extremely cheap to figure out when and how to plant crops. And they're applying this to small villages in India. These places in India are impoverished and don't have access to that technology. But by simply putting some devices in the soil and then applying cloud AI computing to it, we can actually drive an outcome that took experts at the edge of their field even 30 years ago in one place. We can give them that capability all across the world at a very, very low cost. So we're seeing this happening over and over again. Another area, and this is something that Robert Downey Jr. talked about a little bit, is trying to clean up the planet. I think it's a great goal. It's going to be hard, but things like World hunger could actually be ended by AI. Again, not a consequence most people in the AI world are thinking about, but by scaling expertise and making these things cheap, we have a huge implication upon the world that can move towards a much better set of outcomes. But one thing is interesting is that at these technology transitions, we have this sort of hype cycle, if anyone's familiar with this. At first, it's like, oh, wow, wait, there's some new capability out there, and everyone gets super excited about it. They want to think through the possibilities. We kind of ride up this curve. We start to get to the peak, and it's like, wait, this is actually really hard to do. And then people start talking about all the reasons that it's not going to work. But they don't tend to talk about the unintended consequences. They're really just talking about all the reasons that technology is going to be hard to build. And then we sort of slowly dig our way out and figure it out. So I think the same thing is true for the ethical and societal implications for technology transitions. Like, you know, how will this impact my business? How will it impact society? How will it impact our human experience? We don't tend to think about those things. I think with AI, we have to think about those things. So this is an example of something like this. It's actually kind of an interesting one. So everyone's probably familiar with the iPhone in 2007. These are actually some headlines from that time. And, you know, they were talking about all the reasons it won't work, right? Because it's the first time someone's come up with this new paradigm-changing phone. There have been smartphones that kind of sort of failed or not really. This is all the reasons it won't work. And a lot of them are actually focused on the technology part. Like, it doesn't have a physical keyboard because, you know, the BlackBerry had that. You know, it doesn't have a good touch sensor for how you move the cursor around and things. So applying old paradigms to this, it didn't really work. But not a single person thought about the implications it'll have on the way we work. Turns out cell phones actually, we thought would decrease our workday because we can work from anywhere, but it actually increased the length of our workday. I don't know if anyone actually was aware of that, because we tend to be sitting around on social media or texting our friends and being distracted from work. So oddly enough, we built a device to make ourselves more productive, and it turns out to make our workday longer. Sort of unintended again. So if we were a little bit more thoughtful about it, maybe we could have steered it away from that. But we are where we are. So let's think about computer vision for a moment. This is something that most of this room has probably heard of at this point. It's basically the ability of computers to kind of look at an arbitrary scene or video and figure out what's in it. You know, there are humans there, there are faces, there are faces, and you can map those to identities. So this could be a huge technology. You could literally find kidnapped people. That's something we couldn't do at scale before. So you're scaling the expertise of face finding. It could speed up entrance lines at concerts or other events. It could, you know, ease our check-in process for airports or getting on planes. All great things. We could even use these techniques to say, in an office environment, for instance, is the AC running when there are people there, or are they not there? And so you can actually count how many people are there and sort of optimize your operational costs. But what's the potential downside of that? I think a lot of people in this room could probably figure that out. It's a little bit creepy, right? You got this thing watching you at work, and it's like, is that really a good thing? I mean, personally, I don't like that. I don't want somebody watching me. I don't know what's on the other side of the camera. And so it turns out that could actually decrease productivity even though you're trying to save money. So we need to think through these possibilities before we actually get to a point where we deploy them at scale, because at scale, the implications can be quite large. So without intention, these negative outcomes can become our future, and we don't want to do that. We want to have an intentional, positive future. And so what we're really trying to avoid is this, right? I think I use this as sort of the caricature of all bad stuff around AI. Right? So this is the symbol. We don't want that. We don't want the Terminator, right? I don't think the Terminator is actually likely. It's just really something that I get asked a lot. It's like, you know, when Elon Musk says that the Terminator is going to happen, isn't it actually going to happen? It's like, well, probably not. But the reality is that we can actually lead our society into bad places if we're not careful. So what can we as business leaders do to start moving toward an intended future? So we're seeing that there is impact on businesses today that's positive. And we're at the very, very early days. So we've seen that, you know, very broad categories of customer acquisition and decision making and organizational productivity are actually increasing due to AI. These are studies that are kind of ongoing, and we see a lot of headroom for improvement. And this is even characterizing new kinds of AI like reinforcement learning and other things. So there's obviously benefits there, but if we can start being a little bit more thoughtful about when we roll these things out, we can have something where this transition actually realizes the positive benefits without the negative, or mitigates the negative. It's actually a really interesting study on how this could happen is this Just Do It commercial from Nike. I don't know if you guys remember this Colin Kaepernick example from last year. If you recall, this is when the whole kneeling thing was going on, and potentially there's some negative there. And the traditional way to roll out an ad was really to look at what the response would be before you send it out. And if we did that the traditional way, Nike would have never launched this ad. But what they actually used was sentiment analysis using machine learning from Twitter feeds and things like that to test it. And it turns out this ad, while controversial, actually led to the company's value increasing by about $6 billion. So I would say they kind of nailed it. It worked. And they did that because they were able to find more subtlety. So that's a really good outcome. And they did it in a way that was kind of incremental. Here's another really interesting one. I don't know how many in here are familiar with OpenAI GPT-2. So this is a cool technology demonstration. This is actually a slightly different thing that you're seeing on the screen called a transformer, but similar idea is that it's language modeling that allows you to type in the beginning of a story or a sentence with a missing word, and actually fills in the rest. If you looked at Robert Downey Jr.'s talk yesterday, they had the thing with Alexa where they're throwing up all this funny stuff. You can actually do that. I don't think that was that. Correct me if I'm wrong, anyone in here, but I think that was written by a human. But we can actually do that with a trained neural network that basically scrapes information from the internet and comes up with stories. So, you can type in these funny things, it'll write all these stories for you. It's actually quite entertaining. So if you go to talktotransformer.com, you can go play with that. So how could that be misused? Well, the reality is OpenAI didn't open source the GPT-2 implementation and the trained neural network because they were afraid of how it would be misused. So that's we're already hitting that point where there's some tools coming out that are extremely powerful that we're already second guessing, oh wait, maybe we shouldn't make this open yet, and somehow put some controls around it. And there's another implication I think that's really interesting and near to my heart is interfacing directly with humans and not extending our capabilities, but also helping people who are disabled. So back in my PhD, I worked on neural prosthetics. So if you see that little thing attached to this woman's head, it's actually connected directly to her brain, listening to individual neurons. And we use machine learning algorithms to pick up what her movement intention is. This patient happens to be paralyzed from the neck down, but she can still think about movement. And so we use machine learning to interpret those signals and then drive the robotic arm. So she's actually driving that robotic arm for the first time, able to give herself a drink in over 10 years. This is old. This has actually gotten a lot better now. This was, I don't know, about 8 or 9 years ago at this point. So we're seeing that the conjunction of robotics, AI, and biology is going to lead to some really interesting possibilities. And again, achieving more scale, more productivity for us, but also changing what it means to be human. Imagine all of a sudden, if it's a little bit like the Matrix, you can plug something in and you can operate things that in kind of a native format, just like your arms and legs work today. That's a little bit different, right? It sounds scary, but in reality, it just changed what it means to be human. It didn't really diminish our importance as humans. So there's some really good work going on into the transparency behind AI, and this I think is a very important concept, and unfortunately I don't have a lot of time to talk through it because I want to get to the recommendations here. But some groups are really working on how we can make AI explainable and really open the box up a little bit so people are a little bit more at ease about how decisions are being made, and we can start working toward beneficial outcomes. So how do we keep this going? Well, first principle is really be thoughtful. It sounds simple, but people aren't always thoughtful when they get excited about rolling out technology. So starting small is extremely important. Sometimes implications are unknown, as we just saw. We have the opposite sometimes happens when we roll something out. So how do we make sure that we are moving towards the intent of our technology? Well, Twitter did something really interesting. They have another app called Little Twitter Sandbox. And what they do with that is actually roll out new features in a small population, I think it's a few thousand people, and see how it changes interactions. And so then they can test in the sandbox and sort of minimize the impact before they actually roll it out. I think we need to have testing infrastructures like this for AI. Any kind of AI system should always have a sandbox before you roll it out. And we're seeing that happen at the scale places like Google and other places, Amazon, but we need to do that more in the enterprise. And everybody, all business leaders should really be thinking about this. It's not so easy to just take an open source tool and just implement it. It may not lead where you want it to go. Security. Security is extremely important here. As we move to a world where data and data sovereignty become extremely important to individuals and groups of individuals, security is the technology solution to help us get there. So as a technologist, I like to use technology solutions because they're kind of they're sort of easier to implement and roll out. We don't need to change the way we work as a society. Of course, that's going to be part of this. But we have technologies today that actually help us in the ML world around security. So for instance, homomorphic research is showing some promise as a way to show end-to-end encryption for things like healthcare. I can send a piece of data to a cloud service that's running a neural network algorithm and get an answer back in an encrypted form, and nothing along the chain actually knew anything about my data. So that's really key to making these things happen. There are a number of other things like multi-party computations and other things that can obscure individuals' data and keep things private. So we have to think about security from the get-go. It's not an add-on later. And I think this might be the most important, is being transparent. It's still early days in AI. Not everyone is comfortable with it. Don't assume it to be so. Let's understand how decisions are being made, whether it's an autonomous vehicle or even a healthcare experience or a buying experience for something else. Being transparent with your users on how these decisions are being made and the oversight that went into it is something we should strive for. And this is a bit of a cultural change. So what we found is that teams that were focused on ethics tend to have more successful AI deployments. That's an extremely important thing. It's actually leads to your bottom line. If you don't focus on ethics, you're wasting money. So as a business leader, that should get your attention. So review AI output. Again, reviewing AI output, making sure it is in a sandbox, doing what you want it to do, actually leads to better AI deployment. So again, hits the bottom line. Just being very thoughtful, putting a process in place for these things, and reviewing your outcomes as to what you believe is the right outcome is extremely important to seeing successful implementations. And changing the conversation. Basically, what I meant by what I mean by this is being transparent with when and where you're using AI. So some companies are using AI for HR processes. Tell your employees that. At least they understand this, and they can actually help you debug it. It's like something weird happened. This is an input. So we need to be continually testing and adapting these systems. There is no closed-form solution for an AI problem. They tend to be things that we continually adapt and patch. So let's take the unintended and make it intended. That's really the goal here. So I want to move from this outcome to this outcome. And in 10 years, I really, really hope to see some really interesting headlines like robots ready for Mars colonization and healthcare costs drop for 12th straight year in a row, and no more car crashes. So let's work toward this better world. Thank you all.